chemistry, I have no idea what's going on right now.
What part of chemistry?
VSEPR shapes, like, I don't know what they look like or anything about them.
That's a big subject. I know how to draw it. Do you want me to help you?
Yeah, that'd be awesome.
Okay. Here. Let's find a picture.
What does it look like? Linear, trigonal, planar, bent or angular. What does it look like? Tetrahedral, trigonal, pyramidal, bent or angular. What does it look like? Trigonal, bipyramidal, seesaw, T-shape. What does it look like? Linear, octahedral, so square, pyramidal. What does it look like? Square, planar, T-shape, linear.
Do you want to dissociate yourself from a relationship? Do you want a stronger bond, attraction with another individual?
If you answered yes to any of these questions, singledisplacement.com is the right place for you.
Single displacement helps you find someone that will potentially have a stronger attraction with,
It works by finding a match that has a stronger personality than your partner.
and you'll be forever satisfied by the product. Join now for 1 month free trial. To be a member is only $25.99 a month.
Only $25.99 a month, but that's only if you call now, and you get 2 months free. Not 1, but 2.
Singledisplacement.com.
It's worth the reaction. Thanks for helping me.
See, it wasn't that hard.
No, it wasn't too bad. You just have to start getting used to it, and finally when it starts coming, it works.
Yeah.
That makes sense.
Yeah, you just have to draw it out.
Yeah. But how do you draw like the other ones that have more? Some of them have 6.
I know.
How do you draw those? Especially these lone pairs, you call them?
Yeah. Do you want me to show you?
Yeah. Hi, welcome back to Chemistry with Rachel. So we're going to learn about angles today for VSEPR shapes. So one thing you always have to remember is bonding pair hates bonding pair hates lone pair, and lone pair hates lone pair. And it goes in increasing strength in that order. So first we're going to look at our linear shape. So we have 2 bonding pairs connect to our central atom. So bonding pair hates bonding pair, so they're trying to get as far away as possible. So this creates then a 180-degree angle. So next we move on to our trigonal planar shape. So you have 3 bonding pairs connected to your central atom. So this creates then a 120-degree angle between all sides, so here, here, and here. And then, take one off, you have one then lone pair at the top. This then, the lone pair doesn't like the bonding pair, so it's gonna push these down a bit more, creating this as a less than 120-degree angle. Then we move on to our tetrahedral shape. So there's 4 bonding pairs connected to the central atom. So it's kind of going out and in here. So these then have a 109.5-degree angle between here, 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 and here. So take one away here. Since this lone pair hates the bonding pairs and the bonding pairs are still repulsing each other, this then puts it down to 107-degree angle, so here, here, and here. And then if you remove another one, you have your bent or angular shape again. So this then moves the angle to 104.5. See? Okay. Then we move on to our trigonal bipyramidal shape. So we have 5 things connected to our central atom. So again, the bonding pairs repulse the bonding pairs. So this creates a 90-degree angle here and a 120-degree angle between here, here, and here. So when there's a lone pair, it's going to be the farthest one away from the bonding pairs because it repulses the bonding pairs more than bonding pair repulses bonding pair. So this creates your seesaw type shape here, creating this a less than 120-degree angle here and a less than 90-degree angle here. Then, where you take away of 2 lone pairs, this creates your T shape, so you can kind of see it. So this creates then a less than 90-degree angle here and here. So lastly, we move on to our octahedral shape. So there are now 6 things bonded to our central atom. So this then creates a 90-degree angle between all of them. So here, 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 here. So then we're going to move one of them. So this now creates our square pyramid. So this has a less than 90-degree angle here and here. So, and then you have two lone pairs. It creates your square planar. So see, it's kind of a square here, and since that the lone pairs repulse each other so much, they're at the opposite ends. And this creates a 90-degree angle between all the bonding pairs. Then, if you remove this one, to have three lone pairs, you're going to create your T shape. So then you have a less than 90-degree angle between here and here, and here and here. And then lastly, if you have four lone pairs with your octahedral shape, it then creates your linear shape, making 180 degrees again. And that's Angles with Rachel. Yay! Do you like music? Of course you do. Music speaks to us. And sometimes when we hear a song, it brings us back to our childhood, to special memories. So, you know what I think you need? I think you need Chem Pop. What is Chem Pop? They're amazing chem songs performed by the top-notch scientists of today's world. Songs include
The story of my compound, I retrosynthesize it.
We're gonna send the electron flow to the cathode, so it's gonna be spontaneous, cause it's gonna need no electrical outlet. Think about it before it takes the electron, life's so short and I'll need sulfur to every cell, every cell. Go galvanic!
What does it look like? Linear.
I know you love those songs, and there's plenty where that came from the Chem Pop people. So, if you want to buy their CD, which I know you do because they're amazing, buy it. So, it's going to be a purchase of $24.99. Yes, $24.99. It's definitely worth the price. Please call 1-800-525-5999. Thank you. Bye now. Hi, welcome back to Chem with Rachel. So first we learned about the VSEPR shapes and their names. Then we learned about their angles. Now lastly we're going to learn about their polarity. So, I have cards here. So, this is going to be our central atom is A. X are going to be our bonding pairs. And when you see an E, it means it's going to be a lone pair. And if you see an X with a dotted line around it, it just means a different atom than the other one. Okay, so as we know, this is our linear shape. It has an 180-degree angle. So, is it polar or nonpolar? That's sort of a question that we always have to think about when we're answering some questions. So, we're going to look at the axes. So let's just say that these two, they're the same atom, but they have a higher electronegativity than the central atom. So that means our dipoles, or we can call them our arrows, are going to go this way and this way. Basically it's just saying this is going to be slightly positive and it's going to be slightly negative. So, how does that tell me if it's polar or nonpolar? Well, look at it this way. I can fold my paper and you can see that the arrows cancel each other out. So that's going to tell me that it's nonpolar. But if we look at this scenario where this other atom has a higher electronegativity, so it's going to pull this way, and then this X is going to pull this way because this has a higher pull. So yeah, if you fold your paper, the arrows sort of cancel out, but their charges don't. Because this is slightly positive, and this is slightly positive, so it's moving this way. So almost think of it as two friends are fighting over you. One has this arm, one has this arm. Well, if they're both pulling you this way, then you're going to be nonpolar because you have an equal pull on both sides. But if your friend on this side is stronger, you're going to go more towards this side than you are this one. So that's going to make your molecule polar. So we're going to move on to a trigonal pyramid. So we know it has a 120-degree angle. So if you look, all the axes are the same atom. So basically, equal pull everywhere. However, you put a lone pair, it's going to make the pull different. So it's like, yep, they're both pulling up, but there's nothing to balance it out at the top. So it's going to make it a polar molecule, whereas this one is a non-polar molecule. So the same thing goes for even if you just change the atom that has a higher electronegativity on the top, it's still going to pull all towards the top, making the bottom more slightly positive and the top like more negative. So that creates an imbalance, so it's going to be polar. Next, we move on to our tetrahedral shapes. So we have our first one here. So it has all the same x's here, have our 109.5 degree angle. So it's going to be a polar molecule because it's equal balance, everything's being pulled directly, all the charges are canceling out, so we're good. But then, if we go here, we add a lone pair in, and we know our lone pair repulses, so it makes the angle smaller, 107. So basically, if my x's have a higher electronegativity than my central atom, it's going to go this way, and this way. But there's nothing to cancel out one of them, so it's then going to be a polar molecule. And lastly, when we look at our bent shape for tetrahedral, it's also going to be a polar molecule because, yes, our charge is here, so it's going to be like going here and going here, but they can't cancel out because you have two lone pairs up here. And a good example of this shape is water, because we know water is superpolar, and it's superpolar because of its shape, also because of its hydrogen bonding, but its shape is the main reason why. So when we look at everything else, so when you go on to look at your trigonal bipyramidal shapes and all the things that fall underneath it, as well as your octahedral shapes with the T-shape and all those things, always think of these general rules. Always draw your dipoles or your arrows. That way you can be ensured that they cancel out and you know where they're going. So with that being said, know your electronegativity trend on your periodic table. So it goes from left to right and bottom to top. So basically, if all your arrows or your dipoles cancel out, it means you're going to have a non-polar molecule. But if your arrows or your dipoles don't cancel out, you're going to have a polar molecule. So that's it. Now you're totally good with VSEPR shapes. Now there's two. Nope. There's only two shapes. How is that? Another one.
Holler at her. Hey, girl.